Number 11, the key to doing the surface area is to recognize that the opposite sides are going to be the same area. So like, for example, this part right here is the same as the part on the back. And so if I find the area of the front, then I just multiply by 2 to get the back. Similarly, these two pieces on the left side, if you add those two together, you're just going to get the area of the part on the right. And so you can just do the part on the right, multiply by 2, and that'll give you the sum of those other two. And then the same thing's true about the top. The two top pieces, when added together, are going to be the same as the bottom. So we can simply do the surface area equals 2 times, well, the bottom is just 16 times 12, which is 192. The right side, which is these two added together, is just 9 times 12, which is 108. And then we got to work a little bit harder for the front. The way I'm going to do it is I'm going to cut it off right here. And so this is 5 because this over here is 5. So 16 times 5 is 80. So this little piece right here is 80. And then what's left is a 4 by, well, this is 4 because 9 and 5, 9 minus 5 is 4. So 4 plus 4 is 16. So 80 plus, or 4 times 4 is 16. So 80 plus 16 is 96. Adding those together, you get 300 plus 96. So 396 times 2 gives you 792. For the volume on this one, there's two ways you could have approached it. The first way, the easiest way, is to recognize that if you consider the little L shape, the base, then this would work as a prism because the faces are all rectangles. If you kind of stand it on end, and so that L's on the bottom. And so we can just say the volume is just the volume of the area of the base, 96, which we just calculated here, right? Times the height, which is 12. And when you multiply those together, you get 1,152 meters cubed. Now, if you didn't see to do it that way, the other way you could have done it is recognize that it's just a rectangular prism, this one right here, plus a rectangular prism, which is the one on top. And so the bottom rectangular prism here is just going to be 12 times 16 times 5. And so the other way you could have done your volume is 12 times 16 times 5 plus this top part here, which would be 4 times 12 times, and remember we said that height there was 4, so 4 times 12 times 4. So this little bit here is also 4. And if you multiplied those out, you would also get 1,152. So either one of those ways would work as the volume for that one. All right, for 16, it says a sphere has a surface area of 36 pi. Well, you need to remember the formula for the surface area sphere, which is 4 pi r squared. And we set that equal to 36 pi. And we just need to solve this equation to find r. So we divide through by 4 pi. That gives me r squared equals 9. Take the square root of both sides, and you get r equals plus or minus 3 because you put the square root in, but the radius can't be negative, so just positive 3. And then it says, what's the volume? And so the volume of a sphere is 4/3 pi r cubed. And so you just substitute your 3 in for your r. And that turns out to be 4/3 pi times 27. And so you end up with 4 pi times 9, which is 36 pi. And so this is an example of when the volume and surface area of a sphere are the same, at least the same numerical value. They'd have different units, right? One is units squared, the other is units cubed, but numerically they're the same. All right, the last one is a cylinder. Cylinder has surface area of 174 pi. And so your surface area of a cylinder is 2 pi r squared, the two bases that are circles. That's where the pi r squared is a circle. You get two of them. Plus 2 pi r h, that's the lateral area. And that's going to have to equal 174 pi. Well, we got two variables here, so that's not good. But that's okay because we know what the radius is. It's 6. And so we can substitute that in for r. So it's going to give me 2 pi times 36. 2 pi times 6 times h equals 174 pi. So that gives me 72 pi. When I do 36 times 2, I get 72 pi. Plus 12 pi h equals 174 pi. Subtract the 72 pi. And that gives me 12 pi h equals 102 pi. Divide through by 12 pi. The nice thing that happens is the pi's cancel, so that gives me h equals 102 over 12, which turns out to just be 8.5 or 17 over 2. Problem asks for your answer in the nearest tenth, and so we need to find the volume of the cylinder to the nearest tenth. We found out that the h is 8.5, and so it's just going to be volume equals pi r squared times 8.5. And since it asks for the nearest tenth, we just need to multiply that out in our calculator. So 36 times 8.5 times pi. And you get 961.3. And so the volume of this cylinder with a surface area of 174 pi is 961.3.